All right, we're going to try the problem that we just did, WAMAP Unit 3, Problem 7, a different way. So in the first video, I converted all of these fractions. We did a prime factorization of the denominators of these fractions and determined that 12 would be a great denominator for all of them. Converted them all to twelfths, and then we didn't have to convert them again for the rest of the problem until the very end when we had to reduce them. And then for this one, we're just going to treat this the same way we do with all of our algebra. We're just going to look at these like whole numbers and just move things around and convert them as we need to when we add or subtract them. So let's get right to it. I'm going to subtract 5/6 x from both sides. Okay, so this 5/6 x is going to go away. It's canceled out. And over here we have 5/2 x minus 5/6 x. And we have to convert 5/2. We need the same denominator, so we're going to multiply the top and the bottom by 3. And we'll get 15/6 x minus 5/6 x. And so it's just a matter of subtracting 5 from 15. We'll get 10. And our unit there is sixths. That's the denominator. And then x, 10/6 x. And that plus 3/4 is equal to 2. Okay. Now we're going to subtract 3/4 from both sides. Subtracting 3/4 here and 3/4 here. So 3/4 minus itself is 0. That leaves 10/6 x equal to 2 minus 3/4. So 2 can be written as 2 over 1 minus 3/4, and we still need to have the denominators the same. So we're going to convert by multiplying the top and the bottom by 4. And so we're going to get 8/4 minus 3/4, and that's going to be equal to 5/4, right? And that's 10/6 x is equal to that. So now we have this fraction we're trying to isolate x, and ultimately you always want to have x as a single 1x and positive. So the quickest way to do that with a fraction is to multiply by the inverse. And you can also get to the same conclusion by just applying the inverse operation rule. What's happening to x here? It's being multiplied by 10 over 6. So we're going to divide by 10 over 6. And we divide both sides by 10 over 6. So once you've done this for a while, you can see, oh, I can use an inverse and eliminate that 10 over 6 completely. So if we were to say 10 over 6 x divided by 10 over 6, so we're multiplying by 1 and we want to divide by that very same number. So division in fractions, we invert and multiply, which is kind of the whole idea of the inverse operation. So we have 10/6 x times 6 over 10. And we're going to get 60x over 60, which is 1 over 1, which is 1/6, which is x, 1x. We can cross cancel these and get just x, 1x or x. And that's going to be equal to this number divided by 10/6, which is the same as saying 5/4 times 6 over 10. And we can do the same kind of cross-canceling here. Let's get blue. We can divide 5 and 10, have factors of 5 in common. So we can divide this by 5 and get 1, and divide the 10 by 5 and get 2. And then 6 and 4 have 2 as a common factor. So we can take out a 2 here and get 2, and take out a 2 here and get 3. And then we multiply these smaller numbers together. And the whole point of that is that you have a smaller number, you're less likely to make a mistake or get a headache. And so 1 times 3 is 3, and 2 times 2 is 4. And so we see here x is equal to 3/4. And this is the same answer we got. Of course, you should always get the same answer, no matter what method you use. But it's the same answer that we got on the previous, using the previous method. So if you're comfortable with that prime factorization, you can go ahead and start with that and make all the denominators the same. But you also have the option to just power through and treat it the same way you would as if you were using whole numbers. It doesn't matter. You just got a couple of extra rules to follow when you're using fractions, like the equivalent fraction and convert so that you have the same denominator. If you have any questions with any aspects of this problem, please contact me. I'm happy to work with you. I have math office hours every Monday at 10 in the morning. But I'm happy to set up other times if you have a busy schedule and you can't meet at that time. There's also the Math Learning Center. And those links are in Canvas in our Canvas class. Okay, so please give this a try. Either use 7a or 7b, one or the other, and stick with whichever method makes sense to you. Okay, good luck.